Just like we've looked at common factors, we'll look at common multiples. Now, for finding out common multiples, let's take a couple of simpler examples. Let's say we have to find the common multiples of two numbers, 15 and 6. Okay, so let's list down all the multiples of 15. So 15's first multiple is 15 times 1, 15. Then the next is 30, 45, 60, 75, 90, 105, and so on, right? Now the multiples of 6 are going to be 6, 12, 18, 24, 30. Then 36, 42, 48, 54, 60, and so on, right? Now if 15 has these multiples and 6 has these multiples, then if I have to list down the common multiples, they're going to be all the multiples which are common across 15 and 6, right? So the first such multiple that I see which is common across 15 and 6 is 30, right? The second such multiple that I notice common across both of them is 60, right? Now, is there a trend here? I mean, if I just complete 120 here and so on and so forth, you notice that the common multiples are 30 and 60 and so on, right? So clearly there are going to be more common multiples. In fact, there are going to be infinite number of common multiples across any 2, 3 or more than 2 or more than 2 numbers, right? Now, is there a trend in how common multiples are occurring? Yes, there is. So for 15, in this specific case, for 15, it's every second multiple of 15 is a common multiple, right? So the 30 is a second multiple, 60 is the fourth multiple, 90 is the sixth multiple, and so on, which are going to be common across 15 and 6. And for 6, it's every fifth multiple. You notice 30 is its fifth multiple, 60 is its 10th multiple, and so on. Now given this trend, right, we can clearly make out without even going any further, is that common multiples are going to be 30, 60, 90, 120, and so on, right? So the common multiples are going to be a trend. They are going to follow this trend, and they are all going to be, very interestingly, multiples of this number, right? Now if they are all going to be multiples of this first number, and there are infinite common multiples, 30 becomes a very important number, which is called the lowest of the common multiples, right? So 30 becomes a very important number, and it's referred to as the lowest common multiple. Now can I ask you, just like we asked the last time, is there any point calculating the lowest common factor? The answer was no. Likewise, can I ask you, is there any point calculating the highest common factor? The answer is no again. Why? Because the common factors, they will continue all the way until infinity, and the highest common factor is always going to be infinity. So there is absolutely no point wasting your time trying to calculate the highest common factor. So always you stick to finding the lowest common multiple or the highest common factor, right? Now let's talk about a few more interesting things about HCF and LCM. Now let's take the example of let's say 24 and let's say 30. Okay, now what I'm going to do is I'm going to take all the examples, all the factors. I'm going to list down all the factors of these two numbers. So 24 will start with 1 times 24, then 2 times 12, then 3 times 8, then 4 times 6. So that's all the factors of 24. For 30, we are going to do 1 into 30, 2 into 15, 3, into 10 and 5 into 6, right? So 24 and 30 have all their factors listed below. Now let's list down the common factors. The common factors are 1, 2, 3 and 6, right? So these are all the common factors across 24 and 30. Now clearly the highest common factor is 6, right? The largest one. Now can we do the same exercise as we've done for 24 and 30 here and see what happens if we list out all the factors of 6? So let's list down all the factors of 6. So 6, the first factor pair, 1 into 6. The second factor pair, 2 into 3. That's it. So 1, 2, 3 and 6. So all the factors of 6 are 1, 2, 3, 6. Now take a look here. The common factors across these two numbers are 1, 2, 3, 6. 1, 2, 3, 6, 1, 2, 3, 6, right? So interestingly, the point I'm trying to make here is that all common factors are always all the factors of HCF, right? So in case there is some way of finding out the HCF directly, then I would not even need to worry about listing down all the factors of 24, listing down all the factors of 30 and picking out which factors are common. All I would need to do is do this exercise for the HCF straight away and I'll have all the factors which are common across these two numbers, right? Now let's look at this from the multiples point of view. Now if we list down in the previous example, I'll just use the previous example. So we had 15 and 6 and the multiples of 15 were 15, 30, 45, 60, 75, 90, 105, 120 and so on. The multiples of 6 were 6, 12 and then there was 30, 36 and then there was 60 and then there is 90 and then there is 120. So we've seen that the common factors are every second multiple of 15 and every fifth multiple of 6, then 4th and 10th, then 6th and 15th. So 6th multiple of 15, 6th multiple of 15 and 15th multiple of 6, then 8th multiple of 15 and 20th multiple of 6. So the common multiples are 30, 60, 90, 120, right? And so on. And there's infinite of them. So if we list down all the multiples, all multiples of 30, then do I not get this same table, right? So the point here I'm trying to make is that if we know the LCM, then all multiples common will be all the multiples of the LCM, right? So in HCF, just find the HCF, list down all its factors and you'll get all the common factors. For LCM, just find out the LCM and write down all its multiples and you'll get all the common multiples.